Hello everyone. Today's topic is recursion. Today we are going to learn what is recursion, um, how we can solve a problem using this recursion technique. First of all, I'm going to explain you what recursion means. Later on, I will show you some examples where the recursion technique has been applied. So basically, what is recursion? We can say recursion is a way of thinking to solve a problem. Basically, we can say it is a method for solving problems. So the basic idea is that a method that solves a problem by solving a smaller versions of the same problem by breaking it down to smaller sub-problems. That is, we have a problem, we break it down to smaller problems and solve those smaller problems, then pull it together to get an answer for the bigger problems. Before going to apply the recursion technique, we have to know how the problem is defined if we think like a recursive way. So first of all, we have to know what is a recursive definition of a problem. Let's take a look to an example. Let's take a look to this numbers. How we can define this list of numbers. So uh, one way of saying this is a list of number which has one or more numbers which are separated by comma. And for recursive way of thinking or recursive definition of this problem should be something like this is a list which is either a number or a number comma list. Okay, so basically the recursive definition is be a list is either a number, or we can say a list is either a number comma another list. So following this definition, we can divide this problem like as follows. For example, 24 is a number comma another list 88 comma 30 comma 37, right? Similarly, we can divide this list from the previous definition as a 88 30 comma 37. Okay, so after implementing recursively the definition, we get the list something like that. We have 24 as a number, then we have the comma, and then followed by another list 88 30 and 37, and then we apply the recursive definition here again in the list. So you have 88 as a number, then the comma and another list 30 comma 37, and so on till we get the single number which is 37. Okay, so this is how we can define a problem in a recursive way. Okay, so take a look to this graph or diagram. This is a recursive diagram of the same problem where the list is divided as a number comma list, and this is called as a recursion tree for a recursion problem. So any kind of recursion that you formulate, you have to have kind of a recursive diagram. So basically you have to know how the problem is dividing it sub problems and how it is going to solve this in a recursive way. Okay, let's back to our definition. So now we know what is recursive definition. So in general, we can say when we formulate a recursion problem, we have to find out two parts. So basically two parts. One is a non-recursive part, the another is a recursive part. So non-recursive part is basically known as the base case or stopping criteria. That's mean that part that cannot be subdivided, or the problems cannot be break down to more sub problems. This part is the non-recursive part. For our example, the non-recursive part was getting to this number 37. From that we cannot divide the list, and the recursive part was having those lists. That's 88, 40, 37. This was the recursive part where we can further divide the problems. So when we design a recursion problem, we have to have in count there should be always two parts, one the non-recursive part, another is the recursive part. There can be more than one base cases or stopping criteria depending on the problems, but make sure when you design a recursion problem to have in count that you have written all the base cases. Otherwise your recursion will get to the infinite loop or infinite statements. So you have to be careful when you design this problem using recursion. Okay, so this is how we define mathematically what a problem when we implement recursion. So recursion is sometimes called or similar is to mathematical induction. So when we design a problem, when we have to apply this recursion technique, first we have to find out the mathematical or the recursive definition of the problem. Then we have to implement in our code. So then come the recursive definition first of all. Then we have the recursive programming. So what is recursive programming? Recursive programming is basically defining a method that calls itself. Okay, so let's take a look at an example where we talk about a recursive problem. Everyone knows what is a factorial of a number, right? Factorial of a number. So how it is defined? For example, 5 factorial. How we define 5 factorial is something like 5 into 4 into 3 into 2 into 1, right? This should be the answer of 5 factorial. Can you think about this problem as a recursive way of thinking? We can say this is a number into factor of another number, right? So can we write something like that? 5 factorial is equals to 5 into 4 factorial. That can be written, right? Similarly, we can divide the 4 as a 4 into 3 factorial. This can be done, right? And so on till we get to my base case. So in this case, the base case is 1, right? So do you see which parts of the problem is recursive and which parts is not recursive? So this one is my non-recursive part. This 1 factorial, 2 factorial, 3 factorial, 4 factorial are the recursive part of the problem. So if I have to define it like in terms of n for 7 factorial or for 8 factorial or for any kind of factorial, the definition is always kind of similar to this: n into n minus 1 factorial, right? So this factorial is called itself calling with the factorial. That means we are defining a problem using the same concept, right? So this is the recursive definition for the factorial problem. Okay, so take a look to this image which explains basically how the factorial for 5 factorial finding works from 5, 4, 3, 2, 1. Then when you get to the base cases, we start returning. That's if we get the result of the smaller problems.